MPLS, or Multiprotocol Label Switching, is a technology used in computer networking to efficiently route data packets across a network. It's commonly used by Internet Service Providers, ISPs, and large organizations to improve the speed and manageability of network traffic. MPLS operates at the data link layer and network layer of the OC model. At its core, MPLS works by adding a label to each data packet's header. This label contains information that helps routers make forwarding decisions without needing to perform extensive packet analysis at each hop. Instead of examining the entire packet's header at every router along the path, only the MPLS label needs to be looked at, which makes the routing process more streamlined and faster. Here's a simplified breakdown of how MPLS works. Label assignment. When a packet enters the MPLS network, the ingress router assigns a label to the packet. This label is unique within the MPLS network and corresponds to a specific route. Label distribution. Routers within the MPLS network exchange label information using protocols like Label Distribution Protocol, LDP, or Resource Reservation Protocol, RSVP. This ensures that all routers along the path know how to handle packets with specific labels. Label switching. As packets move through the network, routers make forwarding decisions based on the MPLS labels. They consult a label forwarding table, which maps incoming labels to outgoing interfaces. Label swapping and popping. At each hop, the router looks at the incoming label, consults its label forwarding table, and swaps the incoming label with the outgoing label. In some cases, the label might be popped off, removed, if the packet has reached its destination. Efficient routing. Because routers only need to look at the label, the forwarding process is faster and requires less processing power compared to traditional routing methods. Traffic engineering. MPLS also allows for traffic engineering, which means network administrators can control the flow of traffic more precisely by assigning different labels to packets based on various criteria. This enables better utilization of network resources and optimization of data paths. MPLS networks offer benefits like improved network performance, better quality of service, QoS, management, traffic isolation, and the ability to create virtual private networks, VPNs, easily. However, newer technologies like segment routing, SR, and software-defined networking, SDN, have emerged as alternatives or enhancements to MPLS in some scenarios. Overall, MPLS has been a crucial technology in the evolution of modern networking, helping to make data transmission more efficient and reliable. MPLS introduces a concept called label switching. Instead of relying solely on IP addresses, MPLS assigns a label, a short identifier, to each packet as it enters the network. These labels are used to direct the packets through the network, and routers make forwarding decisions based on the labels. This creates a more efficient and deterministic forwarding process. Here's a simplified overview of how MPLS works. Label assignment. When a packet enters an MPLS network, a label is assigned to it. This label corresponds to a specific route or forwarding path. Label distribution. Routers in the network exchange information about the labels they use and the routes associated with them. This information is distributed using protocols like LDP, Label Distribution Protocol, or RSVP, Resource Reservation Protocol. Traffic engineering. Label switching. As packets traverse the network, routers use the labels to determine the next hop. This is much faster than traditional IP routing because the forwarding decision is based on the label, not the full IP address. Label swapping. Routers can swap labels as packets move through the network. This allows for efficient routing of packets along predefined paths. Label popping. When a packet reaches its final destination, the label is removed, popped, and the original IP packet is forwarded based on traditional IP routing. MPLS provides several benefits, including faster packet forwarding. Since forwarding decisions are based on labels, MPLS can lead to faster and more deterministic routing compared to traditional IP routing. Traffic engineering. MPLS allows network operators to control and optimize the path that specific traffic takes through the network, improving overall network performance and utilization. Quality of service. QoS. MPLS enables the prioritization of different types of traffic by assigning different labels or classes of service. This is useful for providing consistent performance for applications with specific requirements, such as voice and video. Virtual private networks, VPNs. MPLS can be used to create secure and isolated VPNs, allowing multiple customers or business units to share the same physical network infrastructure while maintaining data separation. Overall, MPLS is a powerful networking technology that helps address the challenges of scalability, efficiency, and performance in modern networks. It provides a flexible framework for managing and optimizing data traffic, making it a fundamental component of many large-scale networks.